You walk into your physics class expecting the usual equations on the board, a few demonstrations, maybe a pop quiz if your teacher is feeling ambitious. But what if I told you that hidden beneath the surface of those everyday lessons are secrets, tricks that can make physics not just easier but mind-blowingly cool? Tricks that most teachers never mention. Not because they're hiding them, but because sometimes the most astonishing parts of physics get lost in the rush to cover the curriculum. Today I'm going to show you 10 physics tricks your teacher never told you. Tricks that will change the way you see the world, and maybe even give you an edge the next time you're stuck on a problem or just want to impress your friends. Let's start with a question. Have you ever wondered why some people seem to get physics instantly, while others struggle? It's not just about memorizing formulas. It's about seeing the hidden patterns, the shortcuts, the little-known principles that make the universe tick. And once you know these tricks, you'll start to see physics everywhere, in the way a coin spins, the way your phone charges, even in the way you walk down the street. Trick number 1. The center of mass illusion. Imagine you're trying to balance a broomstick on your finger. Most people instinctively try to keep their finger directly under the broom's center. But here's the trick. If you focus on the top of the broom, not the bottom, your brain automatically makes the tiny adjustments needed to keep it balanced. Why? Because your eyes pick up on the larger, slower movements at the top, giving you more time to react. This isn't just a party trick. It's a real application of physics. The higher the center of mass, the slower it moves for a given force, making it easier to balance. That's why tightrope walkers use long poles. They're not just for show. Next time you see someone struggling to balance something, tell them to look up, not down. You'll look like a genius. Trick number 2. The inertia hack. You know Newton's first law, objects in motion stay in motion. Objects at rest stay at rest. But did you know you can use inertia to your advantage in everyday life? Try this. If you're carrying a tray full of drinks and someone bumps into you, don't try to stop the tray suddenly. Instead, move with the bump. By matching the motion, you reduce the relative acceleration, and the drinks are less likely to spill. It's the same principle that makes a magician's tablecloth trick work. If you pull the cloth fast enough, the dishes barely move, because their inertia resists the sudden change. Next time you're at a party, try it out. You'll save the drinks and maybe the party. Trick number 3. The hidden power of leverage. Archimedes famously said, "Give me a place to stand and a lever long enough, and I will move the world." But most people don't realize just how powerful levers can be. Take a simple wrench. If you need to loosen a stubborn bolt, don't just push harder. Extend the handle with a pipe. Doubling the length of the handle halves the force you need to apply. This isn't just theory. It's why crowbars, pliers, and even your own arms are designed the way they are. The farther you are from the pivot point, the more power you have. It's a trick that can save you time, effort, and maybe even a trip to the hardware store. Trick number 4. The secret of resonance. Ever seen someone shatter a glass with their voice? It's not magic, it's resonance. Every object has a natural frequency at which it vibrates. If you match that frequency, even a small force can produce huge effects. This is why soldiers break step when crossing a bridge. If their marching matches the bridge's natural frequency, the vibrations can build up and cause real damage. But resonance isn't just about destruction. It's also how musical instruments work, how your microwave heats food, and even how your phone's speaker produces sound. Next time you hear a weird vibration, ask yourself, what's resonating and why? Trick number 5. The conservation of momentum shortcut. In collisions, momentum is always conserved. But here's the trick. You can use this principle to solve problems faster than your teacher ever showed you. Imagine 2 ice skaters pushing off each other. If one is twice as heavy as the other, the lighter one will move away twice as fast. You don't need to know the exact forces or times, just compare the masses and velocities. This shortcut works for everything from billiard balls to rocket launchers. Once you see it, you'll start spotting momentum conservation everywhere. Trick number 6. The magic of air pressure. You've probably seen the classic experiment where you fill a glass with water, cover it with a card, and flip it upside down. The water stays in the glass. But did you know you can use air pressure to lift objects, seal containers, and even create a vacuum with nothing but a straw? Try this. Put a straw in a glass of water, cover the top with your finger, and lift it out. The water stays in the straw, held up by air pressure. It's the same principle that lets airplanes fly and keeps your drink from spilling when you use a travel mug. Air pressure is everywhere, and once you know how to use it, you'll see the world differently. Trick number 7. The optical illusion of refraction. Ever noticed how a straw looks bent in a glass of water? That's refraction. The bending of light as it passes from one medium to another. But here's the trick. You can use refraction to disappear objects, make things look bigger or smaller, or even create your own rainbow with a glass of water and a flashlight. Refraction isn't just a curiosity. It's the reason glasses correct your vision, why the sky is blue, and why diamonds sparkle. Next time you see light bending, remember it's not magic, it's physics. Trick number 8, the power of friction. Most people think of friction as something that slows you down, but did you know you can use friction to your advantage? Try rubbing your hands together to warm them up. That's friction at work. Or use a rubber band to open a stubborn jar lid. Friction is what keeps your car on the road, your shoes on your feet, and your pencil in your hand. But here's the trick. You can control friction by changing surfaces, adding lubricants, or even using special materials. Once you understand friction, you can make things move or stop whenever you want. Trick number 9, the mystery of buoyancy. Why do some things float while others sink? It's not just about weight, it's about displacement. If an object pushes aside more water than it weighs, it floats. That's why a massive steel ship can float while a tiny pebble sinks. You can use this trick to make your own floating devices, test the purity of metals, or even explain why icebergs are so dangerous. Buoyancy is a hidden force that shapes our world, from boats to balloons to your own body in a swimming pool. Trick number 10, the unseen force of magnetism. Magnets are everywhere, from your fridge to your headphones to the earth itself. But did you know you can use magnets to levitate objects, generate electricity, or even create your own motor? Try this. Take 2 magnets and see if you can make one float above the other. Or use a coil of wire and a battery to make a simple electromagnet. Magnetism is one of the most powerful and mysterious forces in physics, and once you start playing with it, you'll never look at the world the same way again. Now that you've seen the 10 tricks, you might be thinking, okay, but how do these actually help me? Are they just fun facts, or can I use them in real life? The answer is both. These tricks aren't just party pieces, they're tools for understanding and navigating the world. Let's dive deeper into how each one can be applied and why knowing them gives you a real advantage, not just in physics class, but in everyday life. Let's revisit the center of mass illusion. Think about sports, basketball, gymnastics, skateboarding. Athletes are masters of their own center of mass, even if they don't use the term. When a gymnast flips through the air, she tucks her body to spin faster, extending her limbs to slow down. It's all about controlling the center of mass. The next time you watch a skateboarder land a trick, notice how they shift their weight, arms outstretched, adjusting in midair. This isn't just talent, it's physics in action. And if you ever need to move a heavy piece of furniture, remember, keep the center of mass low and close to your body. You'll be amazed at how much easier it is. The inertia hack is another trick that's more useful than you might think. Picture yourself on a crowded bus, standing as it lurches to a stop. Most people instinctively tense up, trying to resist the motion. But if you bend your knees and move with the bus, you'll stay balanced and avoid getting thrown off your feet. It's the same principle that helps surfers ride waves and dancers spin gracefully. Inertia isn't just a law, it's a life skill. The more you understand it, the more you can use it to your advantage, whether you're carrying groceries or learning to skateboard. Leverage is everywhere, once you know to look for it. Ever tried to open a stubborn door by pushing near the hinges? It's almost impossible. But push at the edge, far from the pivot, and the door swings open easily. That's leverage. It's why playground seesaws work, why scissors cut, and why you can lift a heavy load with a long stick. Even your own body is full of levers. Your arms, legs, and jaw all use leverage to multiply force. Next time you're faced with a tough task, ask yourself, where's the pivot, and how can I use leverage to make it easier? Resonance might sound like a technical term, but it's behind some of the most dramatic moments in history. In 1940, the Tacoma Narrows Bridge in Washington collapsed in spectacular fashion. Not because of an earthquake or a storm, but because the wind happened to match the bridge's natural frequency. The bridge began to sway, the motion built up, and eventually the entire structure tore itself apart. That's the destructive power of resonance. But it's also the reason you can tune a guitar, why opera singers can shatter glass, and why your microwave heats food so quickly. Understanding resonance means you can avoid disaster, or create something beautiful. Momentum conservation is a shortcut that can save you time and confusion. Imagine you're playing pool. When a cue ball hits another ball, the total momentum before and after the collision is the same. If you know the masses and the speed of one ball, you can instantly figure out the speed of the other. This trick isn't just for games, it's how scientists calculate rocket launches, car crashes, and even the movement of galaxies. Once you start thinking in terms of momentum, you'll see connections everywhere. Air pressure is one of those invisible forces that shapes our lives in ways we rarely notice. It's why your ears pop on an airplane, why weather changes, and why you can drink through a straw. But you can also use air pressure to do amazing things. Try this. Fill a plastic bottle with hot water, then pour it out and seal the bottle tightly. As the air inside cools, the bottle will crumple, crushed by the weight of the atmosphere. It's a dramatic demonstration of just how powerful air pressure can be. And if you ever need to seal a bag of chips without a clip, just suck out the air and twist the top. The pressure will keep it closed. Refraction is more than just a neat visual effect. It's the reason glasses and contact lenses work, correcting the path of light to focus images on your retina. It's why fish look closer to the surface than they really are, and why rainbows form after a storm. You can use refraction to create your own science experiments at home. Place a coin in a bowl, then fill the bowl with water. From the side, the coin will seem to rise up, appearing closer than it is. That's refraction in action, bending light and bending your perception. Friction is often seen as a nuisance, something that wears down machines and slows us down. But without friction, you couldn't walk, drive, or even hold a pencil. Understanding friction means you can control it. Need to move a heavy box? Put it on rollers to reduce friction. Want to stop quickly on a bike? Use the brakes to increase friction. Even in sports, friction is key. Think of the grip on a basketball shoe, or the wax on a snowboard. Mastering friction means mastering movement. Buoyancy is a force that can save your life. If you ever find yourself in water, remember, the more of your body you can keep below the surface, the more buoyant force you'll experience. That's why swimmers float better when they relax and spread out. It's also why ships are designed with wide, flat bottoms to displace more water and stay afloat. And if you ever need to test whether a metal is pure gold, drop it in water and measure how much water it displaces. Pure gold is denser than most metals, so it will displace less water for its weight. Magnetism is one of the most mysterious forces in physics, but it's also one of the most useful. Magnets can pick up metal objects, generate electricity, and even levitate trains. But did you know you can make your own magnet at home? Take a steel needle and stroke it with a magnet in one direction several times. The needle will become magnetized, able to pick up small metal objects. It's a simple trick, but it demonstrates the power of magnetic domains aligning in the metal. And if you ever need to find north without a compass, float a magnetized needle on a leaf in water. It will align itself with the Earth's magnetic field. These 10 tricks aren't just curiosities, they're keys to understanding the world. Once you start looking for them, you'll see physics everywhere, in every action, every object, every moment. And the more you know, the more you can do. Let's take a step back and ask, why don't teachers usually share these tricks? It's not because they want to keep secrets from you. The truth is, the way physics is often taught in school is focused on formulas, problem sets, and preparing for exams. There's a curriculum to follow, a textbook to get through, and a limited amount of time. But physics isn't just a collection of equations. It's a way of seeing the world, a toolkit for solving problems, and a source of endless wonder. The tricks you've just learned are the shortcuts, the hacks, the aha moments that make physics come alive. They're the things that make you say, wait, that's how it works? And once you start thinking this way, you'll never look at a physics problem or the world the same way again. Let's dig deeper into the contrast between textbook physics and real-world physics. In the classroom, you might be asked to calculate the force needed to push a box up a ramp, or the speed of a ball thrown into the air. But in real life, you're constantly using physics without even realizing it. When you ride a bike, you're balancing forces using friction and conserving momentum. When you cook, you're using heat transfer, pressure, and even chemical reactions. The tricks we've talked about aren't just for solving problems on paper. They're for navigating the real world with confidence and creativity. Take the center of mass illusion, for example. In a physics class, you might learn about the center of mass as a point where all the mass of an object seems to be concentrated. But in real life, understanding center of mass can help you move furniture, balance on a skateboard, or even carry a heavy backpack more comfortably. It's the difference between knowing the definition and knowing how to use it. The same goes for inertia. You might memorize Newton's first law, but until you've felt the difference between trying to stop suddenly and moving with the motion, you haven't really understood it. Leverage is another perfect example. In the classroom, you might solve problems about levers and fulcrums, but in the garage, you use leverage every time you use a wrench, a crowbar, or even a bottle opener. The trick is to see the connection between the abstract and the practical. Once you do, you'll start to see opportunities everywhere to make your life easier. Resonance is one of those concepts that sounds complicated, but once you see it in action, it's unforgettable. Think about pushing someone on a swing. If you push at just the right moment, the swing goes higher and higher. That's resonance. If you push at the wrong time, you actually slow the swing down. The same principle applies to everything from musical instruments to skyscrapers. Engineers design buildings to avoid resonant frequencies that could cause them to sway dangerously in the wind. Musicians tune their instruments to resonate at just the right pitch. Once you understand resonance, you'll start to notice it everywhere, from the hum of your refrigerator to the way your car vibrates at certain speeds. Momentum conservation is another trick that's both powerful and practical. In sports, understanding momentum can help you predict where a ball will go, how to catch a fast-moving object, or even how to tackle an opponent safely. In driving, momentum explains why it's harder to stop a heavy truck than a small car. And in science, momentum conservation is the key to understanding everything from rocket launches to particle collisions. The trick is to look for the hidden connections. Where is momentum being transferred, and how can you use that to your advantage? Air pressure is a force that's always present but rarely noticed. It's what keeps airplanes in the sky, weather systems moving, and your lungs working. But you can also use air pressure to do amazing things. Try this experiment. Take 2 flat pieces of glass, wet them, and press them together. The air pressure outside will hold them together so tightly that it's hard to pull them apart. Or try lifting a heavy object with a suction cup. It's not the suction that does the work, it's the air pressure pushing from the outside. Once you start thinking about air pressure, you'll see it everywhere, from the way your car tires grip the road to the way a vacuum cleaner works. Refraction is another trick that's both beautiful and useful. It's the reason you see a rainbow after a storm, the reason a straw looks bent in a glass of water, and the reason glasses and contact lenses can correct your vision. But you can also use refraction to create your own optical illusions. Try placing a pencil in a glass of water and looking at it from the side. The pencil will appear to bend at the surface. Or use a glass of water to magnify small text. Refraction isn't just a curiosity, it's a tool you can use to explore the world. Friction is often seen as a nuisance, but it's also a powerful ally. Without friction, you couldn't walk, drive, or even hold a pencil. But you can also control friction to your advantage. Need to move a heavy box? Put it on rollers to reduce friction. Want to stop quickly on a bike? Use the brakes to increase friction. Even in sports, friction is key. Think of the grip on a basketball shoe or the wax on a snowboard. Mastering friction means mastering movement.